All right, for next question, we have structure Z and X and Y. Phospholipid bilayer. This one you see, not smooth enough, not 顺, 不通, okay? Carrier protein and channel protein. Now, who will pass through which? Let me know I said, remember, this is very big. If it's very big, you should pass through carrier protein. Remember, if it's very big, you should pass through carrier protein. Vitamin E, remember, RDEC is very fat. So ADK, DD and fat. Yes, vitamin E should be under lipid soluble. If it's lipid soluble, you should go to phospholipid bilayer. Lastly, potassium ion, I mean, no choice already lah. Let's go here. Of course, you can also go to um, carrier protein, but it's just that in this situation, you then arrange it accordingly. And also, of course, you see, because this is passive transport, there's no need for passive transport to take potassium ion to carrier protein. Carrier protein would only do large thing, unless when it comes to, active transport, then you can do whatever. Okay, cool. And next one, why is it passive transport? Remember, how do you explain that? Yeah, just talk about the characteristic. The characteristic of passive transport. Again, we know, okay, you all know, they will move down concentration gradient. They will move down concentration gradient. And then no energy required. No energy required. Okay, typical answer lah. Typical answer for your passive transport. This is the characteristic of passive transport. So remember, when people ask you like that, like this, you see, explain why. How to answer the why? Just ask yourself, what is the basic you know about passive transport? Oh, I remember I memorized a few sentences about the characteristic. Here you go. That would be the point. That would then be the point. Okay, yes. Next one. 3, 3, 3. 3, 2, 3, 2, 1. Okay. Question C, they ask you, how can washing hands with soap destroy the virus? Now, this is so out of nowhere, right? Like, you never learn about soaping, you never learn about washing hands, whatever. No, this is just so out of the syllabus. But how you can see here, they did give you a lot. They give you a lot of information. You see that there is protein spike, there is lipid membrane, there is things like that. Then there is also hydrophilic head, hydrophobic tail. Okay, so my one, this is COVID, this is soap. You see that soap has hydrophilic head, hydrophobic tail. Then you see what happened next. The soap comes into here. The soap comes into here. And then it kind of like break the virus. And you see, just surround the whatever protein over here, and it become gone. You see? It become a tiny bubbles that destroy the virus. So you see, the idea is that this whole thing is something new to you. You can just basically 看图讲故事. You can just tell the story from the picture. Don't need to think much. Just tell the story from the picture and see how it goes, basically. Okay, yep. So again, of course, after all, if you think it's too hard, just skip. Of course, you can skip, but I think this question, they give you a lot of answer already. I do think that this is quite good already because they give you a lot of key, and this key should be used lah. This key should be used to actually help you to solve the answer. Okay, yeah. So what do you see here? You see that we have hydrophilic head, we have hydrophobic tail, and you see that this is a lipid membrane, which is then broken by your hydrophobic tail. You see that? Hydrophobic tail is afraid of water, but they are attracted to lipid. Then you see the hydrophobic tail of the lipid, it penetrates into the soap molecule. And eventually, you break it, and that's how you can destroy the virus. So you see, just follow the story. Follow the story, just follow the story. What happened to the soap? The soap has what? As you can see from here, the soap has, the soap has hydrophilic head and hydrophobic tail. In fact, you will learn this in chemistry. It's chemistry from 5. You learn the topic about soap also. That's actually how it works. That's actually how it works. Okay. Yeah. And what happened to your soap hydrophobic tail? As you can see in the next picture. Like I say, 看图讲故事. Whatever you see, you just describe them. Next one, the hydrophobic tail. They will penetrate through the lipid membrane. Correct? Because you have a lipid membrane on your virus. Remember the lipid membrane? You have a lipid membrane, so it will penetrate through the lipid membrane. It will penetrate to the lipid membrane. So with that, you can see the virus membrane is broken. Virus membrane is broken. Okay, the virus membrane is broken. As you can see here, the virus membrane is broken. What happened next? Yes, you see the protein. Remember this protein thingy? This protein is the one that helped the virus enter your cell. Now that this protein is broken, it's detached, and they are now, you see what happened? They are disintegrated. The protein is then be carried away and be gone. So you see, now the protein no longer exists on the virus. Okay, so the virus loses the protein spike, so they cannot enter cell anymore. That's how the virus will stop acting. They'll be gone, they'll be useless because they cannot have the protein spike. As you can see over here, remember the protein spike? Because they cannot have the protein spike. Oh, sorry, spike protein. Sorry about that. Spike protein. So because you cannot have the spike protein, that means you cannot enter the cell. Yep, that's how you try to follow the story and try to make it into the answer. Okay, that's it. Yep. Again, I won't pause here for a while, but let us move on. Let's move on to the last question. Okay. Next one, we have this one, ORS. So what is ORS? Remember, it's a isotonic drink. Why? Because ORS is isotonic to body cell, such that you can supply what? Remember, you can supply water. You can also supply the extra stuff. In this case, you can see that sodium chloride and glucose. I think those are quite important. So you can also supply salt and also supply glucose. So you see, these are important because you don't just to replace the loss of water. You also want to replace the salt and glucose, which is also lost from your diarrhea. Okay, diarrhea is outside, Diarrhea is outside. So if you lost all the water like that, you definitely should drink it back. And again, not just drink back the water, you also need to drink back the salt, the glucose, everything in your body. That's why we are advised to use not just 白开水, not just still water, but you should use ORS or any sort of electrolyte drink. Okay, electrolyte drink. Okay, that's it. That's it for this question. Thank you very much.